Okay, this is from the Core Pure paper 1 in June 2023, the Edexcel, and it's a summation question, which hasn't appeared for those of you who are in between Core Pure 1 and Core Pure 2 this year, 2024. Question like this hasn't appeared yet, so summation series very likely to turn up on the second paper. There was a summation series, well, it wasn't a summation series, there was a series question on the first paper, but it was approved by induction, so nothing along these lines. Now, usually summation series are pretty straightforward and they seem pretty okay. However, this one, it's not a nice one at all, not a nice one at all. And you kind of think you can muddle through most of them, but there's loads of little things in here that you've got to look out for. Part A was literally to explain why this result holds. Summation from 1 to 2n of minus 1 to the power of r, that's always a tricky thing when you've got the negative 1 to a power to deal with. Some function is equal to 1 to n, so not 2n, of f of 2r minus f of 2r minus 1. Now, a lot of the time with series questions, if all else fails, just start writing out the first few terms. See if you can spot some kind of thing developing, some kind of pattern developing. So all I'm going to do to start with is write out the first few terms of this and maybe then continue that on and just see what the last kind of terms will look like. So the sum from r equals 1 to 2n of minus 1 to the r, f of r. So when we stick 1 in there, minus 1 to the power of 1 is just minus 1. F of 1 we're going to get, so we're going to just get it minus f of 1. We then, when we stick 2 in there, every even power, obviously, minus 1 to an even power is just going to be 1. So that's going to be nice. So we're just going to get plus this time, f of 2. And then we can see how this is going to go, because when I go to an odd power, I'm going to get a negative. When I do minus 1 to an odd power, I'm going to get a negative. So it's then going to go minus f of 3. It's going to go plus f of 4. And it's going to continue. I haven't really left myself some room here, but never mind. So, and if we look at the last few terms, so 2r minus 1, for example, is going to be the penultimate term. And that's going to be an odd number, 2r minus 1. So we're going to have a negative. So it's going to be minus f of 2r minus 1. And then when we put 2r in there, that's going to be a nice even number. So we're going to get a positive, and so it's going to be plus f of 2r. That's it, plus f of 2r. Okay, now we can kind of see here we've got a subtraction of these terms. We can see some are minuses, some are pluses. So that's looking pretty good. We can kind of group them together if you like. You could do all the minuses and all the pluses if you like, or a couple of ways in which we can do this really. I'm going to go with this. I'm going to group them like this. I'm going to go right, so that's f of 2 minus f of 1. And then it's plus f of 4 minus f of 3. And then it's plus f of 6, 2, 4, yeah, 6 minus f of 5. Can't add. And then it's going to go all the way, and my last one is going to be f of 2r minus f of 2r minus 1. Now really that should be enough there. Oh, I've got some missing brackets here, dear me. Just trying to group them together like that. There we go. So that should be enough to show that I'm going to go from 1 to 2, but just in case, let's really accentuate the point here. We're now going from 1 to n. So this first bracket, that f of 2 we can write as f of 2 times 1 minus f of, now I know this is stupid, but that 1 is 2 times 1 minus 1. So what I'm basically showing here is that first f of 2 minus f of 1 is that expression but with r equal to 1. Then, this f of 4 minus 3, I'm going to write using that expression, so therefore r is equal to 2. And that really shows that it's I'm building up with r being 1, then 2, then 3, and so on. F of 3 is going to be 2 times 2 minus 1. Just really making sure the examiner is completely convinced, right, I know what's happening here. So 6 is 2 times 3, minus, and 5 is 2 times 3 minus 1. All the way up to the last one, which I don't really have to do anything for, f of 2r, minus f of 2r minus 1. Which is, we can now go r equals 1 to n. Obviously, always remember, last line of a proof should be the thing that they've written. F of 2r minus f of 2r minus 1. All summed from 1 to n. So there it's 1, there it's when it's 1, there's where it's 2, that's where it's 3, all the way up to when it's equal to n. Looking at that, the only thing I've suddenly realised, why have I written an r there? Deary me, that should be an n. Luckily, r's turn into n's really easily. Oh my word. Right. Never mind, I'm not really doing that. Okay, so hopefully that makes sense. So, real key point here, if it all looks a bit horrible, and kind of where am I going with this, just write out the first few terms, see if you can group things together, see if you can kind of see a pattern developing. Okay, so not a nice start really, not an easy proof really, but we're now going to go into part B. And as you can imagine, in part B, we're going to assume that this is going to be used somewhere, and it will be. So, let me just write out what part B is. Just give myself some space. So part B, we're now asked to show, using standard summation formula, so all your sigma r squared and sigma r cubed are in your formula booklet. Sigma r, you have to remember that, half n plus 1. But sigma r squared, sigma r cubed, they're there in your formula booklet. So we've got to show that the sum from r equals 1 to 2n, so all looking good so far, of, first fly in the ointment, minus 1 to the r, plus 2r, squared, another fly, oh dear me, equals n 2n plus 1, 8n squared plus 4n plus 5. Okay, so it would be nice if it was just in this form, minus 1 to the power of r, some function of r. Now we've got the r equals 1 to 2n like they have here, but this is not looking nice at all. R times this, we're going to have to multiply this out really and see if it gives us any hints when we multiply this out. So I'm going to take this left hand side, I'm going to multiply it out and see what turns up and what I can deal with. So let's keep the r out there at the moment. So minus 1r to the r plus 2r all squared. So that's me that squared, that times that is minus 1 to the r squared. Can I just write minus 1 to the 2r? We hopefully realise that. And then I'm going to do that times that and that times that. So I'm going to get 4 minus 1 to the r, yeah, because of that times that, doubled basically. It's going to give me 4 of those. And then this term, 4r squared on the end. Okay, so I've expanded out. I'm now going to times that r in there, and I'm going to separate them out into 3 different summations. That one, and that one all being times by r. So let's have a look what we got now. So summing from r equals 1 to 2n. r times minus 1 to 2r. I'll come back to this one in a minute. Plus 4 times minus 1 to the r. I'm going to bring the 4 out if that's okay as well. 4 there. And minus 1 to the r squared. Now that's going to be r times r. Give me this r squared. So that's what, from r equals 1 to 2n again. And then finally, r times that 4r cubed, and again I'll bring the 4 out. R equals 1 to 2n of r cubed. Okay, right. So, first little thing to think about here. This minus 1 to the 2r. Now, think about that. 2r is always going to be an even number. Because, you know, whatever r you put in there, 2 times it gives an even number. And minus 1 to the power of an even number is always just going to be 1. So this minus 1 to the 2r, lovely, we can ignore because it's just 1 every single time. Doesn't matter what value of r you put in there, that's just going to be 1. So this is just the sum from r equals 1 to 2n of r. And if you're worried about the examiner not thinking you're just cheating and everything, just put a little line in if you like. You can just put minus 1 to the 2r equals 1 for all r. Okay, that'll do. That'll convince them. Now then, okay, shall we deal with this little thing here now? Now, finally, we can use our part A up here. Because we've got minus 1 to the r, check. R equals 1 to 2n, fine. Of some function of r, and our function is r squared. So we're going to have to put our function of r squared into this formula. Okay? Now, if our function is r squared, f of 2r is therefore going to be 2r squared. F of 2r minus 1 is going to be 2r minus 1 squared. So let's see if we can use this from part A. It's going to be 4 still on the outside. Now it's going to change from r equals 1 to n. And we're going to have f of 2r. So our f of r is r squared. So 2r is going to be 2r squared. Subtract f of 2r minus 1. So putting 2r minus 1 in there. So it's 2r minus 1 squared. Let me just rub this out to give myself some space for this one. So we're finally using that part A in this one here. Minus 1 to the r squared, so our function is r squared. So we're going to have to put r squared as our function into this. So f of 2r will be 2r squared. F of 2r minus 1 is 2r minus 1 squared. Now, I'm going to sort that out in a minute because you can see there's going to probably be a little bit of sorting out here to be done. Maybe I'll put another big bracket around this just to show that whole thing is being summed from 1 to n. And finally, thankfully, we've got a standard one here. So 4 lots of r cubed, if you remember, is a quarter n squared, n plus 1 squared. It's in, well, you don't have to remember, it's in your formula booklet. But we've got a 2n there, so be careful. So this is going to be 4 times a quarter. I'll put it in a bracket. N squared, so that's 2n squared. And then n plus 1 squared, so that's 2n plus 1 squared. Okay. Bit of tidying up. Right. Sum to r, great. Half n plus 1, the one that you have to remember, but with 2n put in there. So it's a half n, which is 2n, n plus 1, so 2n plus 1. Okay, now we've got this middle one. So much work to do with this question. So let's deal with this middle one. Okay, when we expand out this whole thing here, 2r squared, so 4r squared, 2r minus 1 squared, so we're subtracting this squared, so 2r minus 1 times 2r minus 1 is 4r squared minus 4r plus 1. And then on the end here, should we tidy up a little bit here? 4 times a quarter is 1, so this is just going to be 2n squared and 2n plus 1 squared. And as usual, don't multiply out at the moment, because at some point, hopefully, we might be doing some factorising out. So don't do any simplifying yet. Maybe possibly that half and 2n we can do, because you know, that's not too bad. But even that, I'll tell you what, I'll just leave that as well. Right, so where are we at now? Half 2n plus 1 plus 4 lots of, right. So the 4r squared minus 4r squared, they cancel. Minus and minus make a plus there. So we're going to have 4, we're going to have 4r minus 1 there, it looks like. Okay. Leave this one alone at the moment. Now separate these out. So we're going to have 4 lots of sum from r equals 1. Bring the 4 out, make it 16 there, r. And then minus sum from r equals to 1 to n of 4. Yeah, bring the 4 back in if you want for that one. Plus 2n squared, 2n plus 1 squared. Okay, I'll tell you what, just in case it confuses anybody, let's keep the 4 outside. So, that summed is just n, so we're going to have 4n there. So, little line here, and then I'll have to do some rubbing out, I'm afraid. 2n plus 1. Sum of r, half n plus 1, and it is just n because we've got a single n there. No, we're not getting 2 n's now. So that's going to be 8n plus 1 minus 4n, and then plus our 2n squared, 2n plus 1 squared. Right, I'm going to rub these lines out. And now it's time to have a good look at what we're trying to make it look like and see if we can do any sorting out here. So, looking like we're trying to prove, we need to take an n out. Well, that's doable, we can do that. Then a 2n plus 1 out, and that's going to be interesting. So let's take the n out first. We haven't got any fractions, so let's deal the half times 2n is n. I'm going to take that out. So n. I've got the 2n plus 1. I'm going to leave that there at the moment, and I'm going to stupidly put another bracket around it, because it will make it easier to see possibly what's going to happen in a minute. Taking the n out there, we're just going to have 8n plus 1. I'm going to write that as 8n plus 8. Then I've got minus 4n, but I've taken the n out, so it's now minus 4. Oh, that looks interesting that we can sort out that. And then taking the n out here, oh, right, okay. So taking the n out, we've got an n squared. So we're going to have 4n squared here. So it's going to be plus 4n still left there. And then we've got our 2n plus 1 all squared. Whew, okay. N. Now then, at this stage, I can imagine a lot of people, once we've done this line, will be going, oh, I've got to take 2n plus 1 out at some point. I might just multiply all this out, get yourself a cubic, and then try and factorise it. And you know what one of the factors is. So we could do that. We'll get away with doing that. You know, get yourself a cubic, take the 2n plus 1 out. You know what it's going to look like. The only problem is, unless you multiply it out and check that your cubic fits, you won't see if you made a mistake or not. However, here's a little thing you might not have quite seen. Isn't 8n plus 4 there? We've got 2n plus 1 there. We've got 2n plus 1 there. Isn't that 4 times 2n plus 1? Yeah, I'll write it out like this. If I take a 4 out there, I've got a 2n plus 1 there. Oh, isn't that nice? Because then, I've now got a 2n plus 1 in every term. I can take out my 2n plus 1. Now, if you didn't see that, I'm sure going through the cubic route, multiplying everything out, getting a horrible cubic, taking the 2n plus 1 out, you get the marks. But you won't know if you made a mistake unless you double check. So let's take 2n plus 1 out, so that becomes 1, that becomes 4, and over here we're going to have 4n, 2n plus 1. This better work. So we've got n, 2n plus 1, and when we multiply that, 4n times that, 8n squared, lovely. 4n times 1, 4n. 1 plus 4, 5. Let's look up and hope. Yes! Lovely. Got it. Okay. So, I mean, that was hard. That was a lot going on there. But hopefully that made sense as we're going through. And like I said, never multiply anything out and don't get yourself horrible cubics and quartics and stuff like this. Leave everything so you can see if any factors come out. But seeing that factor come out, that's a tricky little thing to do. But I think you get away with the cubic, like I said here. Okay, it would be nice if we moved on to the next question, but there's a part C to do. And usually your part C's, they're evaluating a sum here, are quite nice, but this one isn't. So I had a quick go at it, and a couple of things came up, and I just went, oh, that's not nice. So let me just write out what the summation is. Obviously my computers, I really shouldn't make my computer go to sleep, because then I have to keep trying up so I can see what it is again. 14 to 50, haha. So we're now evaluating the sum from 14, r equals 14, up to 50 of, just check they haven't given anything horrible, it's exactly this form. So that's always something to watch. Have they, it's so easy to just go, oh, I'm just putting it in this formula, but just check that they're actually writing out here exactly what we got up here, and they have. So at first glance, you kind of go, oh, that's okay, that's nice. But the thing is, 2n. It's got to go up to 2n. So I'm sure our first line is something that everybody would think of doing. Because it's going from 14 to 50, we obviously want to go from r equals 1 to 50 of this. And then subtract from r equals 1 to 13 of this. Okay, so we're going to be using our formula up here, it seems. However, there's an issue. The first thing to realise, and hopefully not too difficult a thing, is realising this is 1 to 2n. So actually we've got 2n being worth 50. So we're going to substitute in n equals 25 into there. Okay, because it's going from 1 to 2n, we're going from 1 to 50, so that means our n is worth 25. So we can put 25 in there, so what we're going to get, 25, 51, and then, just write out 8 times 25 squared plus 4 times 25 plus 5. Okay, so that's okay. Now this one, and this is where it becomes really just not nice at all. Our problem comes here in the 13. Because I know a lot of people would just go, oh, okay, so 2n, so my n is 6.5. I'm going to have to put 6.5 in there. You can't do that, I'm afraid. You really can't do it. You can't put a non-integer into here. You know, our n needs to be an integer value. And the problem comes is also we've been using this formula, the nice subtraction, if it's 1 to 2n. So therefore it's 1 to an even number. This isn't 1 to an even number. So we can't really use this kind of technique here, because this technique uses the fact that this is going to be an even number up there. So what do? Well, we actually make this an even number by going, right, well, okay, r equals 1 to 13, I've got to subtract. Well, why don't I subtract r equals 1 to 12? Okay, because that I can use, because now I've got an even number, I can use my formula up there. But now, I want 1 to 13, I've done the 1 to 12, I've got 13 still hanging around that I've still got to subtract. Well, that's okay, it's just one term. It's just when you put 13 into that. So now we're going to go back old school and stick 13 in there and subtract that as well, because we subtracted 1 to 12 and we're going to use that formula. But 13 itself, the one that's given us problems, we're just going to stick it in there and work out what actually it is when r equals 13, and that's what we're going to subtract. I've run out of room obviously, so I'm just going to do it underneath. So I'm going to subtract, putting 13 into this formula. 13 minus 1 to the power of 13 plus 2 times 13. There you go. That's what that is worth when r equals 13. That's what we also have to subtract. So it's basically realising, oh, I need an even number up here. So I'll do that, and then anything left over, I subtract that as well. Okay, so I can now, what's that worth? Let me just quickly see. Did I work that out? Yes. It is 6508875, is that right? Oops. 6508875. I'm minus, right, sticking 12 in there. So that means my n is worth 6. So let's go. It's 6, 13, and then 8 times 6 squared plus 4 times 6 plus 5. So I can use this formula up here because I now got an even number. That's r equals 1 to 12, so my n is going to be worth 6 in there. And then I subtract this. Now, I'm minusing therefore 13. Minus 1 to the power of 13 is just minus 1. Oops, I forgot the squared, sorry. And 2 times 13 is 26. Whoops. Doing well here. Squared. I'm sure loads of you are looking at this just going, oh my word, he's not, he's left the squared out there. Where else have I left the squared out? Oh my word, just doing really badly here. Never mind. Okay, so now is, well, we can work this out, 6508875 minus, I'm not bothering this, 6 to 13, 8 times 6 squared plus 4 times 6 plus 5, and I'm minusing, what's this, 13 times 625. Let's get 25 squared, which is 625. Whew. Plug all that in and you get a final answer, which I did work out. And I've actually, where is it? I've got the mark scheme as well, so that's nice. 647 6024 647 6024. Done. Whew. Not nice at all, but hopefully that makes sense. Some real tricky things to focus on here, and like I said, just be careful with this where it's 2n. We can't stick 6.5 into our formula. It's got to be an integer we're going to be putting in there. Okay, hope that makes sense.